As we start into section 9.1, part 1, we're going to be looking at solving quadratics. So we know how to solve linear equations, now we're going to look at solving quadratic equations. And today we're going to focus on two specific ways to do that. We're going to look at solving by factoring and solving by square root property. There are 4 ways to solve a quadratic equation. Now remember, a quadratic equation is an equation with a square in it. So for example, a quadratic equation might be something like this. So if I'd ask you to solve for x in a quadratic equation, you can't just get the x by itself because there's actually 2 separate x's that are not like terms. So you actually have to use these 4 different ways to do it. And there's a time and a place for each 4 of them, and that's what we're going to talk about. Today, we're going to focus on factoring and square root property. Your next set of notes will be completing the square, and then your next set of notes will be quadratic formula. All right, so the first method of solving that we're going to look at is solving by factoring. So the way that you know solving by factoring would be appropriate is if you're able to factor, period. If you look at an equation or a quadratic and you determine that it's not factorable, obviously solving by factoring is not going to work. So the way that you know that solving by factoring would be an appropriate method is if you're able to factor. So you got 3 steps here. We've done it several times before, so this shouldn't be anything new. You set the equation equal to 0, you factor it completely, and then you separate each factor and set those each equal to 0. So let's take, for example, 2x squared equals 18. Let's say I asked you to solve this. The first thing you'd want to do is set it equal to 0. So I'm going to minus that 18 over and set it equal to 0, and then I'm going to take a minute and look at this and see if it's even factorable. At this point, if it's not even factorable, we're going to have to look at another method. So as I look at this, I notice first that there's a GCF of a 2 that I can pull out. I'm still left with a squared, so I know I'm not done, and I notice that that's actually difference of squares. So this is factorable all the way through, so factoring would be an appropriate method. Now at this point you want to take each of these separate factors, there's 3 of them, and you want to come over here and you want to set each one of them equal to 0 by itself. So the 2, you set that equal to 0, the x minus 3, you set that equal to 0, and the x plus 3, you set that equal to 0. And then what you're going to do is take each separate one of these and solve them and you'll get your answers. So let's start with 2 equals 0. Well, 2 doesn't equal 0. This is not even an equation, and so it's null and void, we can get rid of it. X minus 3 equals 0, we would add that 3 over and we would get x is a positive 3. X plus 3 equals 0, we would subtract that 3 over and we would get x equals negative 3. The 2 of our answers, therefore, would be negative 3 and positive 3. And remember, we're going to use braces here because we're saying, hey, I've got multiple answers. That's what braces mean. All right, for our second method today, I'm going to talk to you about using the square root property. So the square root property is just yet another way to solve for x when you have x squared in an equation. So factoring, you can solve by factoring when it's factorable. Square root property is actually easiest to use if there's no middle term. And I'll show you what I mean in a minute by that. But if there's no b term in the middle, if you've just got your ax squared and then your constant and there's no middle term in there, square root property is a little bit easier to use. Other than that, it works for most cases. So let's look at square root property. First thing you want to do is isolate the squared term. So whatever is being squared, you want to get it by itself. Then you square root both sides and you solve for x. So the first example I want to look at is 3m squared plus 54 equals 0. So let's say I was looking at this problem. I could try factoring, and maybe it is factorable, maybe it's not. But I notice that there's no middle term. I've got my ax squared and my c. There's no middle term in here. So I'm thinking using square root property would work well. So the first thing I want to do is get that squared term by itself. So I'm going to minus that 54 over. Then I'm going to divide by 3. And I end up with m squared equals 18. My squared term is by itself, so I did number 1. Number 2 says once that squared term is by itself, actually go ahead and square root both sides. So what happens over here is the square root symbol is canceled. What happens over here is we end up with a square root that we can reduce. There's a couple things that are going on here. First of all, I physically had to go in and write that square root. And since I physically had to go in and write that square root, I physically have to go in and make sure to write a plus minus. We didn't do that in the last section because we didn't write the square root most of the time. In this case, we are writing the square root, so we need to go ahead and write the plus minus. Now, there's a couple other things. I notice I've got a negative, which means I'm going to have an I, and I've also got an 18 that I have to reduce. So I'm going to come down here and I'm going to reduce my 18. Divided by 2 is 9, divided by 3 is 3, divided by 3 is 1. Looks like I get 3 root 2. So the 3 that's circled is going to come out with the I. The 2 that's not circled is going to go back in. It looks like my answer is positive negative 3I root 2. Now remember, when we have a squared, we're going to have 2 answers. If we had a cubed, you're going to have 3 answers. A fourth, you're going to have 4 answers. So if I have a squared, and if I forget to write that plus minus, I only end up with 1 answer. That's a good indication that you're wrong. That's why you have to have that plus minus. In other words, one of my answers is positive 3I root 2, and the other answer is negative 3I root 2. Now I want to look at a separate problem. I'm going to do it in red over here. A little more complicated. It's going to look something like this. Let's say I gave you a problem like this. I could try to factor this, although it would be a mess because I would have to literally take this term, multiply it all the way out, minus the 18 over, it'd just be a mess. I'm thinking as I look at this that my squared term is right here. It's a quantity. This entire quantity is squared, and it's already by itself, which means square root property would be pretty simple right here. So what I would do is, since my squared term is already isolated, is I'm ready to jump in and go ahead and square root both sides. So what happens is that squared cancels, leaving you that 2x minus 3. Now remember, I wrote this square root, so I'm going to write the plus minus. And at the same time, I know the square root of 18 just from my last problem happens to be 3 root 2. So I simplified square root of 18 right away in one step. Now my x is not by itself. Over here on this problem, the minute we square rooted, everything was by itself. My x is not by itself over here, so I've got to do some finagling and some moving. So the first thing I'm going to do is I'm going to add that 3 over. Now remember, we want our real numbers first, or excuse me, our rational numbers first. So that positive 3 is going to pop to the front, and that 3 root 2 is going to pop to the back. So this would be our rational number, this would be our irrational number. We want the rational number to come first. And then I'm going to divide by 2. Well, they actually both get divided by 2. So my answer then is x equals 3 plus or minus 3 root 2 over 2.